Welcome to the final segment of our comprehensive lecture. We have analytically built our understanding of agents up from foundational single-agent skills through the mechanisms of self-evolution and into complex multi-agent collaborative ecosystems. Now, let us examine where this immense academic theoretical power is actually being applied in the real world today. Agentic reasoning is definitively no longer just theoretical lab research. Because these autonomous agents can strategically plan, execute comprehensive searches, expertly use software tools, and coordinate in teams, they are rapidly unlocking entirely new, highly complex commercial domains. In the realm of mathematical exploration and vibe coding, agents are not just passively solving known homework equations. They are actively exploring novel, unmapped geometries, independently identifying and rigorously proving new theorems, and functioning as fully autonomous, senior-level software engineers capable of navigating massive legacy corporate codebases to locate and fix obscure bugs. In the critical field of scientific discovery, we are witnessing the deployment of fully autonomous AI scientists. These agentic systems can independently read and pull data from millions of dense literature papers, generate novel, chemically viable hypotheses, seamlessly use incredibly complex computational chemistry modeling tools to rapidly evaluate and filter theoretical molecules, and even simulate rigorous multi-agent peer review on their own generated findings before presenting them to human scientists. In embodied robotics, agentic frameworks are fundamentally translating high-level, unstructured textual instructions from humans into precise, low-level physical motor actions within environments that suffer from severe partial observability, such as autonomously navigating a chaotic, unstructured 3D home environment to find a specific object. And in the high-stakes domain of healthcare and medicine, sophisticated multi-agent systems are increasingly acting as robust diagnostic ensembles. Instead of relying on a single fallible model, you have an ultra-fast triage agent rapidly mathematically sorting patient symptoms, followed by specialized oncology or cardiology agents debating the nuances of the diagnosis based on the absolute latest real-time medical literature, capped off by a lead physician agent that safely synthesizes the disparate, highly specialized data streams into one finalized, holistic recommendation for the human doctor. However, with all this immense, unprecedented capability comes a huge, immediate problem for the research community. How do we actually rigorously evaluate these agentic systems? Standard, static multiple-choice benchmark tests are entirely insufficient for autonomous systems that fluidly interact with complex, unscripted world environments. The foundational research paper divides modern agentic benchmarks into two distinct critical types. First, mechanism-centric benchmarks. These strict tests evaluate highly specific algorithmic primitives in total isolation. For instance, exactly how reliably can the agent formulate the JSON payload to use a single complex API tool? Precisely how well can it retain a critical piece of information in its long episodic memory over a sprawling 50-turn conversation? Can multiple adversarial agents successfully and fairly negotiate the allocation of a limited resource in an isolated, game-theoretic environment? Second, we require application-centric benchmarks. These broadly evaluate holistic, end-to-end task performance in chaotic, highly realistic simulated environments. For example, the OS World benchmark strictly measures if an agent can autonomously use a virtual computer desktop, clicking buttons and typing text across multiple separate applications, just like a human worker. WebArena rigorously tests an agent's ability to navigate massive, highly realistic commercial websites to successfully make complex flight or hotel bookings. These end-to-end simulations are vital because they test the entire fragile pipeline simultaneously: visual perception, long-term planning, grounded action execution, and multi-agent coordination. As we look beyond the horizon to the future, the rapid shift to agentic reasoning has exposed several massive, unsolved open problems that require urgent focus. Current agents still generally solve fixed, identical tasks. The immediate next frontier is true user-centric personalization, agents that dynamically adapt to you, deeply learning your specific workflow preferences and adjusting their behavior smoothly over years of long-term interactions. Furthermore, there is the fundamental mathematical challenge of long-horizon credit assignment. If an autonomous coding agent takes 10,000 distinct file editing actions to build a massive app and it finally fails compilation at step 9,999, how does the reinforcement learning algorithm possibly know which specific early design decision caused the ultimate catastrophic failure? Optimizing extremely long horizon tasks is mathematically grueling. Additionally, to plan reliably in the physical world, agents desperately need an internal predictive world model to simulate physics and causality into the future before actually committing to acting. Training these world models efficiently alongside the agent is a critical active area of deep learning research. Finally, governance and safety. When you give an AI model persistent memory, multi-agent autonomy, and unlimited access to real-world software tools and APIs, the potential safety risks multiply exponentially compared to a chatbot. We urgently need robust mathematical governance frameworks that do not just align the base language model, but successfully align the holistic behavior of the entire complex agent ecosystem, interacting flawlessly with real-world infrastructure. Agentic reasoning is profoundly accelerating the evolution of AI. It is moving artificial intelligence permanently from a passive paradigm of merely thinking to a highly active autonomous paradigm of doing. And the incredible reality is, we are just at the very beginning of this journey.